Hello guys. Okay, so at this point you should have gotten your 5 topics on Alex completed. And now you are going to be on this flags Desmos, where we are going to continue to talk about linear relationships. Last week our focus was reviewing proportional relationships from 7th grade, and today we're going to start non-proportional relationships and kind of look at the difference between what a proportional and a non-proportional relationship looks like. After this Desmos, you'll be completing the practice um, problems from Desmos. Okay? And those practice problems I may give you on paper, I may give you online. I haven't decided yet. So just be prepared for that. Okay, so the warm up here is a notice and wonder. Press play to watch a flag and its graph. Discuss what you notice and what you wonder. So you're gonna answer this, what you notice and what you wonder on the Nearpod. So the flag is rising, the line. Think about kind of what you notice about where the flag started, where the flag ended, what you notice about the graph, things like that. What do you notice? What do you wonder? Answer that on the Nearpod. Okay, so this line represents the relationship between height and time for this flag, the flag that you just watched. What is the slope of this line? So we want to find two pretty points. This is proportional. It does start at 0, 0, so we can find any um, other pretty point. I'm going to go with this one, but when I do this, I can't think of it as 1 and 2, or I can't think of it as 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8, because my height here from 0 to 8 is actually 8. So just like we did last week with scaling, um, the scales on my X and Y axis are different. Then going over my base, I'm going from 0 over to 2. So this is actually 2. So I'm going up 8 feet. The flag is going up 8 feet in 2 seconds. So what would the slope of that be? 8 feet in 2 seconds. If you said 4, that is correct. That is the slope of the line. It is 4 feet per second is what that means. So what does this number represent in the situation? Because we do the vertical distance, we're looking at our height over time. We're looking at feet over seconds. So it's feet per second. So the flag was being raised at a rate of 4 feet per second. The 8 over 2 ratio that we started with is saying that in 8 feet or in 2 seconds, the flag rose 8 feet. So that's not the unit rate because it's not per 1 second, but that is a ratio that equals 4 feet per second. Okay. Slide number 3. On the previous screen, you said the slope was 4. Write an equation for the flag's height h after t seconds. So last week, with the turtle scenario, we said the distance for the turtle was equal to 3 feet per second, where t was time and t was seconds with that turtle, and d was the distance the turtle went. So remember last week we said the number in front, that coefficient is our slope. So this time, h for height, that is our y, that is on the y-axis. So it's h equals the height of the flag equals 4 feet per second. When you press try it, you'll see that the line matches up with the original. So if it is a proportional relationship, it is going to be the dependent variable, what's on your y-axis, equals your slope times your independent variable, what's on the x-axis. Okay, now we have another flag that we're going to explore. I'm going to press play. Describe the behavior of flag B. And I want you to fully describe it. So tell me, where does it start? Where does it end? And is it going faster or slower than 4 feet per second? Is it going faster or slower than 4 feet per second? For my extended kids, I want you guys to see if you can figure out what the actual speed is. How many feet per second is this going? So my extended kids, figure out how many feet per second is this flag B moving. Okay. So some sample responses from Desmos include the flag B starts higher than flag A but ends slower. So that's like a basic one. Flag B is moving up, again, very basic. Then flag B, this one's stronger. Flag B begins at 8 feet, rises for 6 seconds. So the entire thing is 6 seconds long and ends at 20 feet. Okay. My extended kids, if you said that the flag was rising 2 feet per second, you are correct. The flag B is rising 2 feet per second. Okay. So here is a graph representing flag A over time. Sketch the graph representing flag B over time. So this one, it has that head start just like the one turtle did last week. It's starting at 8. So because of that head start, it is not proportional. It is not going to start at 0, 0. Because at 0 seconds, this flag is actually at 8 feet. So at 0 seconds, we want to put a point at 8 feet. It has this head start right here. Okay. Then we can either use our slope of 2 feet per second. I did not mean to make that larger. No, go down. We can use the slope of 2 feet per second and kind of go up 2 feet every 1 second, but that will be a little bit difficult on this one. Or we can just use our ending point. We know after 6 seconds, this flag made it up to 20 feet. So at 6 seconds, it is at 20 feet right here. So if I connect these two with a straight line, there is that flag. And we can press play to see if we are correct. If you did this incorrectly, let's say that I tried to do 2 feet per second, but I did it wrong. Let's say that I let's say I tried to do this 2 feet per second. It is going to show you where it should have been and how fast the flag that I drew was. Okay. Then also notice this point right here where the two lines intersect. This is saying at this point is at 4 seconds and 16 feet. So it's saying at 4 seconds, both flags are going to be at 16 feet. And you can see that both flags are the same height. Both flags are at that 16-foot spot at the 4-second mark. Okay, so here is a table and a graph with information about flag B. Cho claims flag B rises 2 feet per second, so its equation is H equals 2t. Part of Cho's claim is correct and part of it is incorrect. What is correct and what is incorrect? So go ahead and fill this out. Cho is saying, again, 2 feet per second. And so the equation would be H equals 2t per second. Go ahead and answer. What part is correct? What part is incorrect? Okay. So remember with our equation, H equals 2t, we're saying 2 times the number of seconds should give us the height. So if I look at my number of seconds in the first column, 0 seconds, 2 times 0 would be 0. Well, the height's not at 0 here. So this equation does not work automatically for the first one. If I was to continue and check it for the second one, 1 second, if I did 2 times the number of seconds, 1 second times 2 is 2. Well, the height's not at 2 at 1 second, it's at 10. So this is not correct. But the part that is correct is if we look in this column here, in the height column, this is going up by 2s. We're going from 8 to 10 to 12 as our seconds go up by 1. So what is correct, because the slope of the line is going up 2 feet per second. So Cho is correct about how fast the flag is rising, but is incorrect because the equation does not work for the scenario. And we're going to add on to this because flag B is not a proportional relationship. Okay. So go ahead and add on to that. Okay. Slide 7 here. We have a whole bunch of different things going on. So this says a relationship between two quantities is linear if there is a constant rate of change. It's called a linear relationship because its graph is a line. So everything that we're doing in this unit is looking at linear relationships. It is going to be a straight line throughout the entire unit because our lines are going to have that constant rate of change. They're going to have the same slope throughout the entire line. Some linear relationships are proportional and some are non-proportional. Press the buttons to see some examples. What are some differences between proportional and non-proportional relationships? So these ones are all proportional. Notice where these lines start. Notice what all of these equations look like. Okay. When you click on non-proportional, these ones are like all over the place here a little bit. So notice where they start. Notice what these equations look like. Okay. What are some differences between proportional and non-proportional relationships? Go ahead and answer this. Okay. So, some things I'll kind of give you Desmos's sample response, and then I'll kind of tell you what I'm looking for in a response. So this is what Desmos says. A line that represents a proportional relationship will pass through the origin. A line that represents a non-proportional relationship will not pass through the origin. So that is correct. That is something that we've been talking about. These first lines here, they all start at 0, 0. They all go through that origin, where all of these lines do not start at 0, 0. Something else that I kind of was looking for is the equations. So the equations all have a constant or our constant is a number that is not being multiplied by t. Okay, so in the green one, it's just h equals 40. There is no t there. The red one is 12t plus 16. That 16 is our constant. The purple one, we have h equals negative 4t plus 32. That 32 is our constant. And the blue line, h equals 2t plus 8. That 8 is our constant. So things similar to this. Well, my answer down here actually isn't fully correct. The equations all have a constant. The equations for non-proportional relationships all have a constant. where the non-proportional relationships don't. They're all just h equals the slope t. Okay, slide number 8, we now are introducing flag C in here. So now let's explore the relationship between height and time for a new flag, flag C. Based on the graph, select all the true statements. Flag C is proportional. Well, our green line, does that green line start at 0, 0? No. So it is not proportional. Flag C's graph is linear. Is this line a straight line? Yes, as long as the line is a straight line, it is going to be proportional. The slope of flag C is 8. So let's go ahead and look at this. So flag C has a point here and a point here. So if we rise up from 8 to 16 and then run over from 0 to 2, 8 to 16 is 8. The horizontal here, 0 to 2, is 2. So this one is actually 8 over 2, which does not equal 8. That equals 4. So the slope of flag C is not 8. Flag C rises 8 feet per second. Again, the slope is not 8. And flag C rises at 4 feet per second. That is what our slope means. So C and A are both rising at the same rate, just C has that head start. And notice you can see that C and A have that same rate because these two lines are parallel. If these lines are parallel, that means that they're going to have the same slope. So now we need to go ahead and write the equation for them. So notice that it fixed B. So B, it has h equals 2t. It has that slope of 2, but it started at 8. So C here, its height is equal to, the slope we said was 4 feet per second. So 4 feet times the number of seconds that it's going. And it also has that head start of plus 8. So because of the head start, because of where it's starting, we're going to add 8 to it. And it's going to graph the line of the equation that we did. Perfect. Okay. So here's the equation for flag C. Can you change your equation so that the flag starts high, starts low, moves fast, moves slow? So here you guys are going to experiment. I'm going to give you guys time to experiment on this one. But you're going to change the equation. So here's what it originally gave us with the original graph. Can we have this so that it starts high? If we want it to start high, we have to change the constant. If we want it to start lower, again, we want it to change the constant. If we want to change how fast it is moving, if we want it to move faster or slower, we want to change the slope. So go ahead, play around with this. And I am going to give you an example of something on the Nearpod that I want you to complete. Okay. So synthesis, how can you identify so sorry, a non-proportional linear relationship in a graph and in an equation? Use the example if it helps. So here is our graph with the equations on it. How can you tell which ones are non-proportional? How can you tell which ones are proportional? Go ahead and answer this on your Desmos. This one I am not going over with you. I want to see how well you understood the lesson today. How can you identify non-proportional versus proportional? And you can use the graph and the equation. Okay, here again, I'm not going to go over this one with you because I want to see how well you understood the lesson today. Ada is filling a bucket with water. The graph shows the relationship between the amount of water in the bucket and time past t. Select all the true statements. Again, I want you to, before you do this, pay attention to the scaling. So the y-axis is going up by 20s. The x-axis is going up by 10s. Okay? It gives you the graph and it gives you the equation. So there's already a lot of information in this equation for you. So go ahead, select all the true statements. I'm going to look over and see how well you guys do with this. And then you're going to end the lesson by telling me how well you understood the lesson today and how you felt about this lesson. Again, I wanted you to make sure that you knew a linear relationships Know that there are linear relationships that are not proportional, and I wanted you to be able to describe how to identify non-proportional relationships from a graph or an equation. Again, today, now that you are done with this, you are to complete the practice problems that go along with today's lesson. If you have any questions, please let me know. But I will be grading your Desmos for today that you got it completed, that you kind of want to see how you did with it. And I will also be grading the practice problems. So if you don't get to the practice problems by the end of class, that is going to be on your time to get those done. Again, if you have any questions, please let me know.